In this problem, we are given a random variable x. It has PDF p of x, which is given by this, and the range of x is -1 to 1. We'd like to find the probability that x is in the range 0 to 0.5 first. To find that probability, so what we have to do is integrate the PDF in the required range, which is 0 to 0.5. And then plugging in the expression for p of x, which is this, and then integrating, we get 11 by 32. So that is the probability x will be in the range 0 to 0.5. Next, what we'd like to do is find the expected value of a function of x. And the function we're talking about is x minus 5x squared plus x cubed. To find the expected value, what we have to do is take that function, multiply that by the PDF of x, and then integrate from the over the entire range of x, which is -1 to 1. So plugging in the expression for p of x, we get this, and then integrating this, we get -1 as the expected value of the function of x. The third parameter that we like to compute is the mean mu of x. Mu is given by the expected value of x itself. So this time we're finding the expected value of x itself. So we multiply x by its PDF, p of x, and we plug in the expression for p of x, and integrating over the entire range of x, which is -1 to 1, we get 0 for the mean of x. And finally, we'll find the variance of x. By definition, the variance is the second moment, which is this, minus mean squared. And we found out that the mean is 0, so we can ignore that. So now all we have to do is compute the second moment. So that means we take x squared, multiply that by the PDF, and then integrate over the range of x. And integrating that, we get 1/5 as our answer for the variance. This is when we have just one random variable and its PDF. Now, in the next problem, what we're going to have is two random variables, x and y, and their joint PDF is given. It is x plus y, and the range for x is 0 to 1, and the range for y is also 0 to 1. And the first thing we'd like to find is the probability that x will be in the range 0 to 0.5, and at the same time, y is greater than or equal to 0.5. So we can write it as this probability in terms of the joint PDF as this. So we have to integrate the joint PDF, and so we'll first integrate with respect to x, and the range for x that we are interested in is 0 to 0.5. There is dy missing. So after integrating with respect to x, we have to also integrate with respect to y. And the range for y that we're interested in is from 0.5 all the way to infinity. So initially we write our limit as this, infinity, for the upper limit. But then our PDF, p of xy, is non-zero only from 0 to 1. So that is why in the second step, we can change the limit infinity to 1. And then we plug in the joint PDF of xy. It is x plus y, and integrating that with respect to both x and y. Y first, we get integrating with respect to x first, we get this. And then further integrating that with respect to y, we'll get our final answer for the probability, which is 0.25. And then the next thing we'd like to do here is find the PDF of x, so the marginal PDF of x. To find that, we have to take the joint PDF between x and y, and then integrate out the variable y. So we start with the joint PDF, and the range of y is 0 to 1. So we integrate this joint PDF with respect to y. and the joint PDF is x plus y. Integrating with respect to y, we get x plus half. So this is the marginal PDF of x. Similarly, we can find the marginal PDF of y, which is quite similar. We take the joint PDF and then integrate out the variable x. So integrating with respect to x, we get y plus half as the marginal PDF of y. Then we'd like to find the correlation between x and y. By definition, the correlation is the expected value of x times y. So to find expectation of this function, what we have to do is take that function, multiply that by the joint PDF between x and y, and then we have to integrate with respect to both x and y. And the range for x is 0 to 1, range for y is also 0 to 1. So evaluating this double integral, we get a third. That is our correlation between x and y. Next, we'd like to find the covariance C between x and y. And the covariance is given by correlation minus mean of x times mean of y. This correlation we already found out, it's a third. And then to find the expected value of x, we have to take x, multiply that by the PDF of x and integrate over x. Similarly, we can find the expected value of y as this. And then evaluating these integrals and simplifying, we get 7/12 for our covariance between x and y. And then once we evaluate this, we're also being asked if x and y are uncorrelated, if x and y are orthogonal, and if x and y are independent. For uncorrelated, we need to have covariance equal to 0. Since in this example, the covariance is not equal to 0, x and y are not uncorrelated. Next, for orthogonal, we need to have expected value of x times y. That is correlation between x and y to be 0. And since it is not 0 in this example, they are not orthogonal. And then finally, to see if x and y are independent, we have to see if the joint PDF between x and y can be factored into the product of the marginal PDFs. And in this case, the joint PDF does not factor into that because the joint PDF we have is x plus y, and the marginal PDFs are x plus half and y plus half. So x plus y does not factor into that. That is why x and y are not independent.